This video will show you how to do the practice test for Chapter 3 for the Midchapter test. So it is Midchapter, which is sections 1 through 4. So for question number 1, you're looking for the places in which the function is increasing. So that's the first part of it. So you're looking for when the function is going upward, if you're reading this from left to right, like you would read a piece of paper. So it's going up from the vertex and then everywhere to the right of the vertex. We're really just looking at the x values, so it's going up in this area. So it's going up where x is greater than 3. If you want to write that in interval notation, you can write it from 3 to infinity. Okay, if you want to see that highlighted, it's in this area where it's going up. For where it's decreasing, then it has to be the rest of it in this picture anyway. It's decreasing to the left of the vertex. So this graph, if you're reading it from left to right, which is how you read the increase and decreasing, you read the graph from left to right. It's decreasing to the left of the vertex, so where x is less than 3. In interval notation, you would say from negative infinity to 3. In interval notation, you always have to write the smallest number first, so you wouldn't write from 3 to negative infinity. You have to write from negative infinity to 3. For the next portion, which is where the f of x is greater than 0, so when that means above the x-axis. Okay, so it's above the x-axis. Once it hits here, it's above the x-axis over here, and the graph is above the x-axis over here. So that means that if you look at where the numbers are, okay, to the left of 2 and to the right of 4, the graph is now above the x-axis. So the left of 2 means that x is less than 2, so all the numbers less than 2, and greater than 4. So x is greater than 4. In interval notation, you would say from negative infinity to 2 and from 4 to positive infinity. If you're looking for where f of x is less than 0 or below the x-axis, it's below the x-axis in this area, okay? So only down here. So it's between 2 and 4, okay? So when you would write that, you would say where x is greater than, that's not negative 2, that's positive 2. So between 2 and 4. You cannot write the answer to 1c with the numbers in between because it doesn't logically make sense. And so here you can write it like this. You can also say from 2 to 4. For the next part, when they're asking you for end behavior, that's exactly what they're doing. It's like which way are the arrows pointing at the end of your function when you draw the graph. So this all has to do with what the degree is of your polynomial and what the leading coefficient is. So here the degree is 3, so it's odd. That means the ends are going in opposite directions. And the a value is negative, or the leading coefficient is negative. That means that it's sloping downward, kind of like a line would slope. Okay? And so for the end behavior, when it's asking you the question here, as x goes to negative infinity means as we go to the left, what's happening to the graph? And it's going to positive infinity. It's going up. So that would be plus infinity. As we're going to the left, or as x goes to positive infinity, this graph is moving downward. So that goes to negative infinity. For number 3, this is an even powered, or an even degree. It's 4 is a degree of the polynomial, and it's positive. When it's positive and it's the 4th, it's like a parabola. Both ends are pointing in the same direction, and they're both pointing up. Okay, so that means that both end behaviors are going to positive infinity. Okay, even when you go to the left, it's going up, and when you're going to the right, it's also going up. For numbers 4, 5, 6, and 7, they're matching. And so, again, you're kind of looking just at their end behavior and if they're odd or even. So for number 4, it's an even function, just like this one. The leading coefficient is positive. That means that both ends must go up. So for number 4, it has to go with C. For number 5, it's a negative leading coefficient, just like number 2. It's an odd number, which means it's sloping downward, so that one has to go with A. For number 6, it's a negative x to the 4th. Both ends have to be pointing in the same direction, and they have to be pointing downward because it's negative. Which means that the last one has to be, that's a positive x to the 3rd. I guess it doesn't have to be, but it is. Positive x to the 3rd, it's going upward. And one end is going up, one's going down. So it's sloping. So your answers to these are C, A, B, and D. For number 8, we have to find f of -3. The easiest way to do that is synthetic substitution. However, you can also use direct substitution. I'll show you both methods. So synthetic substitution would look like this. Make sure you use all the coefficients and use any placeholders when necessary. This one doesn't need placeholders. So we have -3 times -3. We add on the way down, multiply on the way up. Add, multiply by -3. And -120. So f of -3 is equal to -120. If I was doing direct substitution, if you were doing direct substitution, this is the work that I would want to see. -3 times -3 to the 4th. You would fill in the -3 for all the x's. And then you would show the work. So this would be -3 times +81, -2 times -27, times 9, plus 21, plus 3, -243, plus 54, plus 45. We add those together, plus 24. These are all positive. They add up to +120. So that gives me -120. So same answer. F of -3 is equal to -120. Continuing on the practice test, when it says perform the indicated operation, you have to decide if they're asking you to multiply, or add, or subtract, or divide, whichever it happens to be. So the first one is multiplication. I'm going to multiply by distributing. You can multiply by using the box method if you prefer. So I'm going to distribute the small into the bigger one because I think it's easier. So that's going to give me 2x to the 3rd plus 8x squared minus 12x. Then I'm going to distribute this -4. So it's -4x squared minus 16x plus 24. And then I'll add those together. So what's the answer? 2x to the 3rd plus 4x squared minus 28x plus 24. But the second one is also asking us to multiply. I'm going to put the 3x minus 4 first. And then I'm going to rewrite it with x plus 1 and x minus 3 second. You can use the box method to multiply this or distribute. You can also just know or use logic of where that would come from if you were factoring. Since that's a -3 and a 1, if you multiply them together, that gives you the last term. If you add them together, that gives you the middle term. That's only true if the first and the second x are both 1x. Next, I'm going to distribute the 3x minus 4 to all of this, the same way as I did in the first problem for number 9. Again, for this, if you rather just use the box method, multiply 2 together at a time and then multiply the third one in, that's fine as well. So if I multiply 3x times all of this, I'm going to get 3x to the third minus 6x squared minus 9x. And then if I multiply -4 times all of this, I would get -4x squared plus 8x and then plus 12. If I add those together, 3x to the third minus 10x squared minus x plus 12. Again, don't put minus 1x there. 3x to the third minus 10x squared minus x plus 12. For the next part, this is just subtraction. So this distributes, so I get 5x squared minus 2 minus 4x squared minus 6x plus 4. So go in order. That's x squared, then the x term, and then the numeric values. So that's plus 2. So x squared minus 6x plus 2. For something to the third power, make sure that you're not tempted into writing 8x to the third minus 125. You are going to take those to the third power, but you have two middle terms as well. You have a 3a squared b, and you have a 3ab squared. Okay, this is a and this is b. So for the first part, I have 3 times a squared, which makes it 4x squared, times b, which is -5. So that gives me 20 times 6, which is 20 times 3, excuse me. So 5 times 4 is 20, 20 times 3 is 60. So -60x squared. And for the next one is 3a, which is 2x, and then b squared, which would be 25. So that's 50 times 3, that's 150. So your answer is 8x to the third minus 60x squared plus 150x minus 125. If you don't want to use a shortcut, then you have to multiply out 2x minus 5, 2x minus 5, and 2x minus 5, and multiply out that completely. For the next one, we're going to be using long division. So we have x to the third plus 3x plus 3 into 3x, that's x squared, excuse me, into 3x to the third minus 2x squared plus 4x minus 3. No placeholders are needed, but you need to always check. So the first part, we're going to divide x squared into 3x to the third. That should be 3x. If you multiply down with that, you're going to get 3x to the third plus 9x squared plus 9x. Then you're going to subtract. So that's going to become a minus, and a minus. That's -11x squared minus 5x minus 3. And then you're going to do x squared into 11x squared, or -11x squared. That gives you minus 11. Multiply down. Minus 33x. Again, you're multiplying these. And then minus 33. Then you have to subtract. So that will give you 28x plus 30. That's your remainder. Alright, so we have 3x minus 11, remainder 28x plus 30. That's a 28x. If you want to write it in fraction form, you would have 3x minus 11 plus 28x plus 30 over x to the third plus 3x plus 3. For number 14, you're going to be doing synthetic division. So since they give you x minus 3, you're going to be using x equals 3 in the synthetic. Inside, you're going to have a 2, a negative 4. We need a 0 for the x squared, negative 12 for the x, and a negative 15. So we bring this down, that's 2, multiply by 3, add, multiply by 3, that gives us 6, add 0 and 6, multiply by 3, that gives us a 6, add 3 times 6, or excuse me, multiply 3 times 6, that's 18, that gives you a 3. That's the remainder. This is a whole number, this is the x value, the x squared value, and the x to the third. They're all positive. So that's your answer. You don't divide anymore. You don't factor anymore. That's the final answer. 2x to the third plus 2x squared plus 6x plus 6, remainder 3. For question number 15, you have to use synthetic substitution to find the value of the function when x is equal to negative 4. So we use negative 4. You have to be really careful because this is an x to the 5th equation. So you need to make sure you account for all of the terms. So you're going to need 2 placeholders in this problem. So we have x to the 5th term, x to the 4th, there isn't one. Then we have x to the 3rd, x squared, the x term, and the regular constant number. So we bring this down, that gives us negative 5 times negative 4, plus, that's 20. 20 plus 0 is 20. Multiply by negative 4, that's negative 80. Add those together, that's negative 83. 83 times 4, that gives you 332. Add that to 0. Multiply that by negative 4. It gives me negative 1,328 plus 4. And then we multiply that 1,324 times 4. So that's positive 5,296. Subtract 7 from that, that's 5,289. So f of negative 4 is equal to 5,289. Your answer is the remainder of your synthetic for f of negative 4. For the next ones, we're doing factoring. We're factoring out the polynomial completely. You always want to start with the greatest common factor if possible. This is just one-step equation. You're looking for the factors of negative 6 that add up to negative 5. So that would be negative 6 and positive 1. Because the 6 is negative, we cannot use 2 and 3. For the next one, we have negative 60 to give us 17. That's negative 12 times negative 5. Positive. Oh no, we can't use that because the 60 is negative. Let me start over. 1 times 60, 2 times 30, 3 times 20. That'll work. So 4x squared minus 3x plus 20x minus 15. I'm using grouping. X plus 5 and 4x minus 3. And you can double check. This is x squared, x times 4x, 4x squared, minus 15 at the end, and this is 20x, and then minus 3x. When there's 4 terms, we start with the greatest common factor. There isn't one, so we're going to use grouping, or you can put it in the box if you'd like. So x squared times 2x minus 3. So this also has to be a 2x minus 3. This has to be a plus 1. So we have x squared plus 1, 2x minus 3. You cannot factor the x squared plus 1 because it's a sum of squares. If it was a difference of squares, you could factor that. For number 19, it is a difference of squares, so that's 7x plus 8, 7x minus 8, and you cannot factor that any further. For number 20, this is a sum of cubes, so this is 5x to the third and 3 to the third. So you have a small parenthesis, which is going to be 5x plus 3. That's a binomial. And you have a trinomial. You're going to square the 5x. We're going to multiply these together, 15x, and change the sign. And the last term is a 3 squared. So we have 5x plus 3, 25x squared minus 15x plus 9. For number 21, greatest common factor is 7, so you want to factor that out first. So that gives you 3x to the fourth minus 11x squared minus 4. So I know that for sure it's going to be 7 times something. So now I multiply 3 times negative 4, that's negative 12 to get negative 11. So it's negative 12 times 1 minus 12x squared, because we're replacing the middle term. So we need an x squared, not just an x, okay? Again, these two numbers that you choose are replacing that middle term. So whether you're using the box method or grouping, you need to have a 12x squared and a 1x squared, not a negative 12x and positive 1x. So then I'm going to group. So I should have 3x squared times x squared minus 4. This will be a plus 1. So that gives me 3x squared plus 1 times x squared minus 4. The x squared minus 4 will be factored into x plus 2x minus 2. So I have 3x squared plus 1, x plus 2, x minus 2. And again, the 7 comes from the very beginning. This part comes from here, 3x squared plus 1. And then you have to factor the x squared minus 4. So your final answer, 7 times 3x squared plus 1 times x plus 2 times x minus 2. Solving by factoring means the same thing as factoring, except for then you have to solve for x afterwards. So you want to set your equation equal to 0 first, if it isn't already set equal to 0. Again, greatest common factor. Or you can divide out the 4 if you want. This will factor into x minus 2 and x minus 1. And then you set your two factors equal to 0. Yes, we have a 4 there, but we're not solving for 4. We're solving for x. So you have x is equal to 2 and 1. For this one, we're going to do negative 10 to get negative 3. This will give us negative 5 times 2. So 2x squared minus 5x plus 2x minus 5. Group x, 2x minus 5, plus 1. So I have x plus 1, 2x minus 5 is equal to 0. Okay, so the whole time we're equal to 0. We set them equal to 0. X plus 1 is equal to 0. 2x minus 5 equals 0. So we have two answers again for x, negative 1 and positive 5 halves. For number 24, I'm going to factor out a 2 first. This factors into x plus 6, x minus 6. We set our factors equal to 0. Put x equals negative 6. And x equals 6. I'm just going to go ahead and put plus or minus 6. Those are two answers. For number 25, That's wrong. I was going to use negative 15 and 2. That's a positive 30. Since that's a positive 30, then I have to use minus 10 and minus 3. So x is equal to 10, x is equal to 3. For number 26, there's a couple questions. Show that x plus 2 is a factor. So that first, I know for sure that it's a factor, so I'm already going to write that here. Same thing with number 27, so that you don't forget to write that down. In order to show that x plus 2 is a factor, we're going to use negative 2. We're going to use synthetic. And we have to show that the remainder will be 0. So we have 1, negative 2, 4, negative 8, 3, negative 6, so that's 0. So this is x squared plus 4x plus 3. So I have my first factor of x plus 2, and then I'm going to finish factoring this. So this factors into x plus 3 and x plus 1. So those are my remaining factors. And we should add f of x in front of this is equal to this. I'm going to go ahead and erase this one and go ahead and put f of x is equal to x minus 7 and then times whatever else I get after I do this factoring. So I'm going to use 7, 3, negative 19. Look for placeholders if you need them. Negative 22 and 56. Again, it has to be a 0 when it asks you to show that it's a factor. Bring down to 3, so that's 21, that's 2, 14, negative 8, and negative 56, so that's 0. So now I have a 3x squared plus 2x minus 8. So I'm looking for the factors of negative 24 that give me 2, which are 4 and negative 6. So 3x squared plus 4x minus 6x. I'm using grouping. Again, you guys can use a box method if you rather. So x minus 2, 3x plus 4. And that completes that. Don't forget that when the a value is greater than 1, you cannot factor in one step like we did here for number 26. Here the a value is 1, so we can just factor that, factors of 3 that give you 4. Here we can't because the a value is greater than 1, so we have to use grouping or we have to use the box method.